We are talking about logarithms and logarithmic functions. We're going to write logarithmic equations, evaluate logarithms, evaluate common and natural logarithms, use inverse properties to find inverse functions, and graph and translate logarithmic functions. The inverse of an exponential function. So here we have the exponential function y equals b to the x. And whenever we're trying to find the inverse, we switch the x and the y. So we have the new function, which is x equals b to the y. Y is called the logarithm of x, or the power to which you raise b in order to get x. Now here's the work that we have. So we have x equals b to the y. And when we're trying to calculate the inverse, we have to get y by itself. So the first thing we have to do is we have to take the log base b to both sides. So we do that in order so we can use our log rules in the next step. So we have the log base b on both sides that we've added. Log rule says that we can take the y out of the exponent. So whenever we take the log, if there's an exponent there, we can move it out of the exponent. Then we can use another log rule that says if you have a log base to the same value that you're taking the log of, that is equal to 1. So log base b of b, that is equal to 1. Right there, that value is equal to 1. So y times 1 is just y. And so we have y equals log base b of x. That's how we can read that. Here we have the graph of the exponential function, which in this case, we have y equals 2 raised to the x power. And then we have the inverse of that function where we switch the x and the y. Both of these graphs are a reflection of each other over the line y equals x, as we can see here. We have the point 0, 1, and if we reflect it over the line y equals x, we get the point 1, 0. We also have the point 2, 4, and reflected we get 4, 2. The asymptote also switches for each of these functions. So right here, the y-axis is the asymptote for the logarithmic function. And here, the x-axis is the asymptote for the exponential function. Logarithm. A function of the form y equals log base b of x, where b is greater than or equal to 0 and b cannot be equal to 1. So the logarithm, log base b of x is equal to y, if and only if x is equal to b raised to the y power. That's in the exponential form, and this is the form that's really going to help us graph the log functions. We have common logarithms and natural logarithms. The common log is log base 10 of x. It can be written as log of x. If there is no base written here, then we understand that the base for the log is 10. The natural log, log base e of x, can be written as ln x. So we have the graph of the exponential versus logarithmic functions. G to the x in both of these graphs represents the exponential function. F of x in both of these represents the logarithmic function. As we can see in both of these graphs are reflection of each other over the line y equals x, which is represented by the green line. And we can take a look at some of the characteristics. The exponential function characteristics, those are the g of x, those are the red functions. The functions are continuous and one-to-one. The logarithmic functions are the same. The domain for the exponential function goes from negative infinity to positive infinity. That's the exponential growth here, keeps going for all x values. The domain for the logarithmic function goes from 0 to infinity. 0 is not included. So we have, in this case, our asymptote is the y-axis. So we're going to get really close to the y-axis, but we're not actually going to cross it. Same thing with the log function over here. The x-axis is the asymptote of the graph. So for the exponential function right here is the x-axis. That's the asymptote for the red graph there, or the exponential function. Over here, the y-axis is the asymptote for the logarithmic function. The domain was for the logarithmic was from 0 to infinity. The range for the exponential function goes from 0 to infinity. So it's going to start here and work its way up to infinity. Similarly, exponential decay is going to get really close to 0 but never cross it, and it's going to start at infinity. The graph contains the point 0, 1. The graph contains the point 1, 0. So those are flipped over the graph y equals x. The exponential and logarithmic functions are inverses. Then the composition of the function should result in the identity function x. So we have f of x equals b raised to the x power, and then we have g of x equals log base b of x. So we have to know these properties. So if we take g of x and substitute it into the function f of x, we take the log base b of x and put it in the exponent. So b raised to the log base b of x is equal to x, and log base b of b raised to the x is x. So these are log properties that we're going to have to know in order to simplify some equations